is admirable, admirable. But anyways, with a sketch like this. So you see, what's the interesting thing about this sketch, right? We were scrolling, but then what caught your eye was the fact that it's not like a full circle, as we might be thinking, or as we might have, it's not like what we're used to. It's a portion of a circle. But then apart from it being a portion of a circle, there's something in it. And let's see, it says the radius of the semicircle center O is 5. So this point here, right? From that point to C, from that point to D, the distance is 5. So put 5 over there, put 5 over there. So the one thing, before I carry on though, this is one thing already before we even read the rest of the question. When you see cases like these, right? Okay, let's maybe read the rest of the question. Maybe what I'll do make better sense. It says now, a square is fitted into the semicircle. So you see here, there is a reason why they didn't just say a block is fitted into the circle. They could have said a block.
So equal,
but they are being specific. Yes, you see, they're being specific. They're trying to tell you that the sides are all equal. Now, if you take that for granted, then there's a problem. So that's why they're telling you it's a square. That's why they're not saying a block. If they said a rectangle, there's a reason for that. If they said a parallelogram, there's a reason for that. That's why properties of different shapes are important, because they will never call a shape by its name because it's fun. No, they'll call a shape by its name because they're trying to tell you to use properties of that shape. Another thing, these are 90-degree angles, and in Euclidean geometry, your 90-degree angles.
I know what to do.
Yes, look at you.
Cut it in half. Cut it to make it a triangle.
You see, you're like in my head now, because things like that. We could have a triangle over there. We could maybe even have a triangle over there, depending on what we need. See, depending on what we need. So we'll leave the lines for now until we'll read what they need. But that's already a way to be thinking of this sketch. In as much as we may not put the lines now, as long as in your head the idea is there, you have one foot in the door. Because having one foot in the door is good enough. That's good enough. So it then says here, a square is fitted into the semicircle, blah, blah, blah. Calculate the area. But then, them asking you to calculate the area, this is a nice hint. I mean, like, hints are not hints just because, they want to write stuff. No. If you find a question and you don't use a hint and you try to do something on your own, it's probably usually wrong. So the hint here says, let the length of the square equal to x. So what that does now is, if this is x, right, and this whole thing is x, and this whole thing here is x, what happens is the whole thing here down here is also x. But what's interesting though is that in as much as all this is x, you see here we have to make use of the 5 measurement here, which is where this triangle now comes in. You see, because this triangle has a radius. You see, and the radius is 5. You get? Yeah. And then what you also know is that this is a square. So if the whole thing here is x and this square is like, touching all the, it's occupying this entire space, right? It just basically tells you that this part here is going to be half of x. This is half of x. This is fully x. And then this is 5. You see? Because remember, a sketch has to help you. A sketch is not there for it to torment you. Don't be tormented by a sketch. The only way this sketch can torment you is if you don't add to it. It's like a give and take. You give it a line, it gives you information. So The one thing now is, okay, statements. Let's give statements for whatever we're going to be writing down here. Like we can say something like let A equal to X, you know, let AE equal to X. But the fortunate thing is sometimes you may not even need to add something like this, because remember in your Euclidean geometry exams or whatever, they give you like an answer sheet with the sketches empty, where you'll be having the sketch and somewhere to write. So the modifications you put on your sketch, they'll be able to see them, and you can. But I think referencing them is always good. You know, let AE equal to X, and then here, as long as AE is equal to X, right? It means that therefore, E is equal to half of X. You know. Now, the one thing you may be thinking is, but fine, we're writing out statements. We have written out this here. This is not necessarily like a statement. It's more like, yeah, adding stuff into the sketch. You don't necessarily have a reason. If you want to write a reason there, I mean, you know, it's you write a reason if you're going to use something to, let's say, like prove something specific. Now here we're not necessarily proving something, we're just laying out. We can what you call, we're just laying out a scenario so that we were able to like use that scenario to answer what we need. So we said OE is half of X based on the fact that everything here is equal to X, right? I'm like, the whole thing is a square, you know. So here AE is equal to X. Here, if you want to say that OE is equal to half X, it's okay. We can say that. So from here, we can say that AE squared plus OE squared is equal to OA squared. Now, this is a very, very deliberate, or this is something we know it's easy to back it up, you know, Pythagoras. Pythagoras. Do this. Pythagoras. You can just say Pyth. You know? So AE equal to X squared. OE is equal to half of X squared. And the last one, 5 squared. This is 25. This is going to be a quarter X squared. It's going to be X squared. So like 1 plus a quarter, it's like 5 over 4 X squared. And then divide by 5 over 4. Yeah, may you please take one for the team with the calculator?
Don't know, I'm using the computer.
You don't have a calculator?
No, I don't have one with me.
Both can't have calculators now. It's fine. I walked to mine. I literally took like 3 steps. You know, I think I'm giving myself away here. I'm not that lazy, you know. It's just that it was just there like, it looks far. I was like, oh, so this is how parents feel. I was like, oh, shit, man, I feel them. I feel for them, man. Dang it. It makes so much sense. You know, all those hours spent getting up, getting the remote. I'm pretty sure it stacked up to like hours, you know, all those 1, 2, 3 seconds, but it's fine. It's okay. This divided by this is a 20. So this is like 20. And then we have to like square root the left, square root the right. So this, what does it give us? 2 square root of 5. No, yes, 2 square root of 5. Does it give you 2 square root of 5? Yeah, it does. It does. X is 2 square root of 5. Oh, wait, I have to confirm with the calculator. Yes, 2 square root of 5. We have confirmed.
Okay. Okay. Yeah. All right.
Yeah.
So X, okay, and then it's okay. Good.